Welcome to module I, lecture 2. This module is on emerging trends in transportation planning. In lecture 1 of this module, we discussed about the advanced modeling topics, basically gave an introduction to activity based model, that how the travel behavior is going to be important, more and more important in the future, and then how the activity based models are emerging in the field. In this lecture, we shall discuss about 3 different aspects. One is the big data, then about geographical information system GIS, and then SDI, spatial data infrastructure. As the purpose is to give you an orientation towards the emerging techniques, emerging approaches, tools. So, these sections will be really brief. We shall not be able to explain you everything in details, but give you a brief orientation and understanding that these are going to be the future of future progress in the area of urban transportation systems planning. First, coming to part A, that is the big data. Now, as over the last 1 or 2 decades, things have changed very significantly. In fact, use of computer, mobile communication, the lifestyle, the way we are using the technology in our day to day life. So, significant changes in individual movements, activity patterns, social networking and use of mobile devices, as well as personal details for commercial transaction and registration, particularly say use of credit card, debit card, online transactions, and all these have led to rapid growth in both digitized and non-purpose oriented data. Non-purpose oriented data includes those kind of data which are collected for a different purpose, but may have a context. Say for me, I am interested in transportation. So, I may still find something interesting in that data. So, example of such new types of data may include the data from transaction, maybe you are paying the tax starting from income tax to every transaction, right. Then the data related to registration, licensing, tracking, see everything starting from vehicle registration data to getting the driving license, everything is digitized and the database is available these days. Similarly, commercial transactions by individuals, especially using credit cards, debit cards, then internet data from search every now and then. Mobile and internet is part and parcel of our life, and you are visiting different website, what you are searching, and even in social networking sites, everything is such informations are available. I mean, whether you like it or you do not like it, such kind of information we are providing every now and then, and such kind of data is available. Same is true for the image data, huge volume of image data, say for aerial and satellite images, land based videos, right. So, all these are new type of data, and interestingly all these data are getting generated in huge volume and getting generated continuously. So, every time period the new data bases are getting generated. So, the data is actually getting accumulated over time and huge database is available. Now, this new type of data which are increasingly available in large quantities are also relevant to planning of transportation system, as they might be relevant for so many other purposes, not only in transportation, but our interest as a transportation planner or traffic engineer is also to see what we can do with this kind of available information, which are available in large quantities and huge data over a period of time. Continuously such kind of data are coming. So, we find that there are also something to do with the transportation planning, because this kind of data provides insights into the location, timing and frequency of activities. Now, if we are using simple my mobile device for tracking a route, I want to travel from A to B, I just put it there in the Google search and Google suggests me the routes and I am moving. So, my movement is, the data is available, right. So, to someone it is available, right. So, it gives me about the location, it gives about the timing of travel and also the frequency of activities. Now, all these are extremely important in the context of transport planning. So, we need such kind of data. So, these are of course of interest to us, and such kind of data may not be specifically captured for transportation applications, but also have relevance to its understanding. Maybe the service provider who is getting this information, he is not getting it for doing transportation planning. He might be getting it because he wants to show where I am along my route and which route I should take and whether I am taking the correct path. And he wants to tell me also that how much time is left for me to reach to my destination. But eventually this data is not collected for transportation purpose, but of course, still it has something or some relevance to me or in the context of understanding of the transportation or the travel behavior or the pattern of the movement of people. So, location, timings and frequencies are activated. Secondly, this kind of data may be archived just to preserve historical transport patterns. You are getting the data and you are accumulating it somewhere, but without an analytical method in mind. Maybe they do not have very much idea or not collected with that kind of idea in mind that I want to do such kind of analysis to derive some insight from this, but they are simply collecting it. Many examples are there for such kind of data. Maybe the vehicle registration data, it is every time the vehicle is registered, the data is accumulated, right, or the driving license, even the accident information, every time the accident occurs, the accident data is recorded somewhere, right. So, police will record the accident data and that digital data in some format or other is available somewhere, right, it is getting archived, right. Probably not with an idea, police probably want to maintain record because they need to maintain the record of accidents and cases and so on and so forth. But that information can also be used by transportation planner, because I want to do some analysis with that accident data and to derive some meaningful insight from it. Availability of the near real time mobility related data, as I said that we are using maybe mobile, we are using the GPS and all such kind of things, number of things are there, right, and which provide me us the near real time mobility related data, and which is just excellent because they provide direct evidence of the volume, the concentration and direction of movement of vehicle or persons, and therefore, could be used for improving the operations, planning and safety of the transportation system. All data, individual level data is available, and it gives me excellent pattern of movement, where in which direction, at what time people are moving, where the concentration is more, the CBD area where people are actually moving, and all such kind of data can be used advantageously for operations planning and safety of the transportation system. So, such kind of data which are huge in volume and getting available over a period of time, digital data may also include, as I said, the non-purpose oriented data, but they still might be useful for us for transportation planning, and all such kind of data may be referred to as big data. The manipulation and management present significant logistical challenges due to very large size of this data. It's because it is getting accumulated large amount of data. So, obviously, the manipulation and management is a problem. So, all such kind of data are normally acquired, stored and interpreted through modern technology. And we have such kind of support system available, because with the advent of technology, many things, as we are able to do it, we are also developing the technology for acquiring, storing and interpreting these data, right. So, significant attributes of this such kind of data, these are the very basic. As I said, we will not be able to teach you everything, it is literally impossible, just an orientation, a brief, very brief orientation rather. So, there are three very significant attributes of such data. There are even more, but I would mention here only three. One is volume, that is increased amount of information, that is the huge volume of information you can say. The other is the velocity, in a way we can say the speed at which this data is collected and the processing is happening, that is another important characteristics. And the last one, which is also very, very important, is the variety, the range of structured and unstructured element that comprise the data set. Okay. So much variety of information, right. That is what, these are the three basic characteristics. Now, the type of big data are basically, there are main two types of data. One is called born analog data, the other is the born digital data. The born analog data is created by an imprint of a physical phenomena, remember that, by imprint of a physical phenomena. For example, through light, sound, motion, magnetic impedance, etc., upon a sensing device and its subsequent conversion to a digital signal. Say, cost of sensor has come down drastically, and that is what has resulted widespread use of the sensors for collecting all such kind of data. So, it may include video streams for surveillance, you can see so frequently we are using it in vehicle, roads, all situations. The motion data, the data related to even the medical or health parameter, the electromagnetic reflection, maybe the LiDAR system, which is again these days used very frequently, even for the transportation engineering purpose, highway engineering purpose, for route alignment and getting the basic data, topographic data and all roads features, even the voice phone calls. So, plenty of examples are there. The other is basically the born digital data, which is produced by design to address one or a series of specific needs, and generally these are created by users or by a computing device specifically for use in a magnetic processing environment. The huge amount of GPS data or any kind of geolocalized spatial data stamp, that is fine. You are using RFID tag, very commonly used, right. Then GSM or Wi-Fi, right. So, device identity, status and location used by mobile devices to stay connected to various networks. Then the data produced by devices, vehicles and networked object. Similarly, as I say, even the emails and SMS. Okay. So, all such kind of the data which also include big data. Now, there are certain important characteristics of the big data which are important for us to get a little bit of understanding, better understanding of such kind of data. One is, I can say, the continuous monitoring, high temporal sampling rate, no gap and all recorded indefinitely. So, over a period of time, this creates historical database that is always growing. So, it keeps growing always, such kind of data, right. Data related to cell phone records, electronic ticket, loop detectors, continuously they are getting the data. Now, the data may not be owned by the data analyzer. I mean, I may be interested in transportation and I may still have something to do, that is what is interesting with the big data, but I may not be the owner of the data. The data may be collected by someone else for an entirely different purpose, but still that data tells me something. So, most cases privately owned by public transport operators may be unwilling to release such kind of ticketing data, because some of the data may they think confidential for them, although I may not be doing, I have no interest in their business probably, right, but still they would like to maintain the confidentiality. So, transfer of non-purpose oriented data is often a challenge, because the person or the group who have the data, they are worried that their confidentiality or their business might get influenced, right, although I may not have any interest in their business. I am looking for, because I am interested in simple transportation perspective, right, and I may use it for to better planning, better operation or better management, but still they may be hesitant to share it. Now, data collection may not have been designed for this purpose. It is linked with the previous reason or characteristics, that they are, because they are not collecting it keeping transportation planning in mind. So, obviously, they want to collect the way it is necessary for them, right. So, I may not get every attribute what I want. So, many cases data from one source might be incomplete. I may not get all the attributes what I want, but still it gives me some idea, some pattern. Okay. So, maybe multiple such sources, the data which are available from multiple such sources, if I put them together, somewhere they make some sense, some meaning, some pattern, right. So, data may be also acquired sometimes outside transport as currently studied. This is an example of work where data from wearable health monitors could be used to explore the relationship between the method of travel, how school children are traveling, and the mean physical level of physical activity for children on their journey to school, right. So, trying to relate this perspective. Now, this data is not collected by transportation people, they are collected for the health monitoring purpose. So, there might be something, it may be a completely outside transport, somebody is collecting data because he is interested that wearable health monitor is telling them, giving them the data to explore the relationship between method of travel and mean level of physical activity for children on their journey to school. Similarly, an ability to link multiple existing data resources, right. So, that is what I hinted also earlier, that multiple sources may give different types of data. So, spatially structured data might be analyzed temporarily alongside the data relating to movement of people and children by different. So, internet data on special event, that is one source, may be combined with electronic ticketing data, right, and altogether all this database may be used to develop a predictive model of passenger arrival at event venue location. That is again a research I have given the reference, right. When I give you the material, all the detailed references will be there. So, this kind of application is possible. Then data is of sufficient scale to apply statistical technique. Analysis of long period of traffic flow. So, any pattern you want to do, such that day of the week or seasonal effect or the climate condition, every effect, because you are continuously getting huge data. So, when the festival is there, how people are moving, and when there is no festival on a regular thing, how the patterns are, you get it. On a weekend, weekdays, get it. When it is too humid or temperature is very high, if you also get the meteorological data, you can relate it, right. So, many patterns we can explore, which otherwise just with the conventional data we will not be able to get, because we will not get so much exhaustive data to explore all such patterns. There are excellent opportunities. In of using this kind of data in transportation planning. Continuous monitoring allows the study of new kind of variation, right. As I said that so much data is available, the pattern can be explored in n dimensions, you can explore the pattern. To correlate with the data on events, on weather, as I said, that when there is a festival, what happens, when there is no festival, how it happened, when it's raining, when it's the temperature is very high, okay, all different patterns, because you have huge data, which otherwise when we design a survey instrument and collect the data, always will have some limitation. We will carry out the data or collect the data only for a few days and try to do analysis, okay, maybe across income, across household size and all that kind of variation we can see, but so much huge variation in the data across so many dimensions that we won't be able to get otherwise, which we can get from this big data. Now, it also provides an opportunity to be less reliant on the stated preference data, because many things which we cannot observe, we actually go and try to get that data for stated preference form, SP form, right. The data may be stated preference data or revealed preference data. So, stated preference data often we use for hypothetical alternative, new alternative, that's a different context altogether. But many cases we still try to get stated preference data, because we do not have scope to observe such kind of things. So, many of those things which not all, right, I would like to remind you, not all, but many of the things, right. If the metro is not existing, I want to see how people would react to metro, I have to still go for SP data. But suppose the climatic condition, how it changes the travel behavior. Okay. Now, I cannot really do the survey throughout the year with so many people, but the big data is available some form or other, and that can give me such kind of pattern. So, new symbiotic relationship could emerge between the data owners and the planning agencies, who are different people, they normally do not talk to each other, but still there is a huge potential and huge opportunity that they can be brought together and do something meaningful for their mutual benefit. So, this kind of opportunities have emerged. Also, greater availability of detailed data seem likely to lead to greater expectation of focused planning, special purpose, special event, special scenario, right. Now, we are doing continuously, we are getting the data. So, more trial and error approaches to policy making, that can happen, right. And this may also facilitate policies that encourage gradual changes rather than drastically or sudden step change. We can do that, because where we do not know what is going to be the outcome or how it is going to be received or what is going to be the impact, we can it allows us to go for gradual changes. Now, big data provides the potential of checking how forecast outcomes of the impact of decisions compare to reality. This your real time data is available, real behavior is available. So, you are readily able to use them for kind of validation. There have been many applications of such data. I have mentioned here some of the very recent works, and say to infer trip pattern, for measuring cycle volumes, for understanding travel or the mobility pattern, mobility related, so many things can be done with this data. To also construct individual movements, for understanding, again this other example is also for understanding the travel or mobility pattern, right, to understand complex travel activity pattern. So, it is really relieving and fascinating. So, I will say that there is a lot of potential to use the available big data and try to extract findings and observations from those to benefit the transport planning and traffic management operations, and overall the benefit people in the transportation context. Now, going to the next part is basically the geographic information system. Now, in transportation, always I have been telling it right from the beginning, the demand is temporal and spatial. If we say that it is congested or demand is more, it is we are referring to a specific geographical location and at a given time. So, any demand or any transport related problem, it has got a spatial dimension, it has got a temporal dimension, and the whole concept of transport planning is built on that. Now, this geographics information system is a framework for gathering, for storing, managing, analyzing and presenting all types of geographical data. So, GIS utilize spatial data in a variety of contexts, operations and applications. So, you can use statistical or analytical technique to this geographical data, generate queries, do all sorts of measurement, transformation, description, carry out optimization with that available data. So, again GIS has opened up a new world to the transport planning professionals. So, whatever we are doing, we still do the same thing, but we do it in a GIS platform. So, there are various applications, as I said, the GIS spatial data is not only used by transportation people. So, if I say it is only transportation, it is wrong, but we also have a stake, right. So, the transport planner, transportation community can also benefit from the use of this GIS for while doing the analysis. So, like many other fields as I have indicated. So, in transportation, number of applications where what we can do actually using this GIS base or GIS platform, starting from navigation to scheduling to locating addresses, then identifying traffic analysis zone based on the land use, even the complete travel demand forecasting. What I have told you, the 4-stage transportation planning, the whole thing you can do in a GIS platform, and that will be much more realistic, and there will be many advantages when you do it for transit planning, for safety management. So, a host of transport applications can be built on this GIS data or this GIS platform. There are different data requirements as you have for the that any kind of, if you want to do a state transportation planning, you need data like road network and its characteristics, you need the transit route schedule, location information, you need household data, land use data, accident data, all such kind of data you can build the database, but in a geographic information system. So, it will be GIS based, GIS database. So, all such kind of spatial data, these are every data is spatial in nature, all such kind of data, and if you see, you will hardly find data in transportation which is not spatial, almost all the data is spatial, right. So, you can build such, and then whatever I said, multiple applications you can do, starting from navigation, finding out the routing, getting the shortest path, scheduling, locating address, and then the doing the traffic analysis zones, right. So, you can, based on the land use, you can produce, you can give much better visualization apart from doing all the analysis which are much more realistic, right, but wonderful representation you can give, visual representation also you can give. Then you identify the traffic analysis zone based on the land use, then the whole travel demand forecasting as you do, starting from the trip generation, trip distribution, mode choice, traffic assignment, the complete 4-stage planning. I am referring to 4-stage, not that only you can do 4-stage planning, but I am referring to this because I have taught you the 4-stage planning in this one, and I am telling that in a GIS platform you can do this whole thing very nicely. And there are specialized software which are available. If you are able to acquire those platforms or can get access to those platforms, then you can take advantage of those things. Also, for transit planning, there are specialized module which allow you to do everything you actually need you are using a GIS platform. Also, the safety management, because safety, if you say accident happens at certain locations, maybe certain intersections are a lot of accidents are happening, or a particular mid block location due to certain deficiencies, lot of accidents are happening. So, you can do accident mapping and then do some analysis and then try to find out the countermeasures or the interventions which are necessary. So, there are multiple platforms, GIS platforms which are available. Many of them have got maybe some basic things you can do in any of these available platform, while some other platform may have little specialized modules to help you to do certain specific things. So, maybe some are just general purpose GIS software, and these platforms can also do many of the things, while some may be little bit specialized, developed based on the specific support for the transport planning, but you can use them and a number of things are there. So, spatial data and the GIS is being used by so many platforms. Now, there are of course unique challenges also related to the GIS data, or if you want to think that you want to do something in GIS platform, it is data intensive, lot of data is actually required, right, because you are developing a spatial database basically. So, it is computation intensive, you need good machines and powerful machines to do that. There is the other consideration, of course, we may not be interested, or transportation people may not be interested, but that is what is also a practical thing, that variable load on the GIS server demands dynamic scaling in out of resources. Then GIS requires high level of reliability and performance. Also GIS use network intensive web service. So, all such kind of things will be there. Something good comes along with certain requirements. So, you have to fulfill those requirements. Now, with this brief introduction, so you can see also, as I said, that the big data is a big opportunity for transportation planners, and the future you can really expect a lot of works to happen, and that is the direction where the transport planner will work. Similarly, transport planners will also use the geographic information system GIS, and more GIS based works are expected. So, we want to do the things what we are doing, but we want to use the GIS to further gain from our work. Okay. The next is basically a related and a continuation beyond GIS, I should say, it is spatial data infrastructure. So far we talked about the GIS, we are talking about spatial data only, but here we are talking spatial data infrastructure. Now, if you see geographically referenced information has become indispensable for numerous aspects of urban and rural development, planning and management. With time, more and more GIS or spatial data people will use, that is bound to happen. Now, transportation planning requires substantial amount of data, and these are spatial data in one way, but there is one more thing which we have not discussed so far, that getting such kind of data required cooperation among multiple agencies. Not that all what you want for the transport planning, you get everything just from one organization. No, the land department, they will have some data that owned by land department, transport department may have the vehicle data. Similarly, the environment department may have the emission data, the police may have the accident data, and if you want to really develop a GIS base, then you need cooperation from all, from everybody you want to need to get the data and develop your GIS. But then who will maintain, who will update it, because you do not have the data. Data will still remain with the police, still remain with environment department, still remain with transport department, right. So, not with one organization, right. So, we need cooperation among multiple agencies. So, as information system advance, the need to provide effective data integration and exchange protocol and procedures to reduce redundancy and data collection cost is becoming more important. So, we are now trying to think in little bit of holistic manner right? They are not just using the spatial data, right? Yes, that is possible, but there are other related issues. How we can promote better use of this GIS data, but by multiple agencies, how we can bring them together, right? How we can avoid the redundancy. I collect the data, I develop a database, then somebody, multiple department, everybody is taking data from others and developing their own database. So, it is a redundancy, and we are increasing the cost of data collection. How to reduce the cost of data collection? How to avoid redundancy? How to make this cooperation among multiple agencies better? So, there are many factors which influence the effectiveness and of data exchange and data integration effort. For example, data compatibility is a very big issue, right. So, people collect data in different formats. So, if everybody collects in different format, then obviously there will be no compatibility of the data. Then the data access, the quality of the data, data completeness, metadata, hardware, software, staff expertise, all these things, because it is not only just using GIS or the spatial data for analysis to benefit the society, but overall think in a bigger way, that in a government framework, right, a government of India or the state, in a state the government is working, right. So, how they can benefit, how the larger society can be benefited, where all such kind of multiple departments or agencies are involved. So, the concept of spatial data infrastructure has been developed to encompass the efficient and effective collection, management, access and use of spatial data. So, all around spatial data, everything is all around, all the discussions are happening, because we understand, we are convinced and we want to promote the use of the spatial data. But then effective collation, management, access, use. How to make all such things better. So, infrastructure implies that there should be some sort of coordination of policy formulation and implementation. Without proper policy, you cannot do anything, right, because when you are multiple departments, multiple ministries are involved, you need policy formulation, right. Without that, nothing is going to work. So, if I have to define, I will say that spatial data infrastructure is defined as a framework of policies, number 1, 2, institutional arrangements, 3rd, technologies, 4th, data, 5th, people. So, framework of policies, institutional arrangement, technologies, data and people that enables the sharing and effective use of geographic information. So, we are also talking about sharing and effective use of geographic and information by standardizing formats and protocols for access and interoperability. So, carefully read this definition, not just for remembering the definition, but for understanding every element. This definition itself, every word is important. I am saying framework of policies, institutional arrangement, technologies, data and people that enables what? Sharing and effective use of geographic information, not only transport. So many things, transport is not in isolation. You cannot deal transport in isolation. There is interdependency. By standardizing formats and protocols for access and interoperability. So, SDI provides a basis for spatial data discovery, evaluation and application for users and providers within all levels of government, commercial sector, non-profit sector, academia and by citizens in general. There will be whichever you think as confidential, you keep it limited, right. You do not give access to everybody, but there are certain things which you can give access to everybody, right. So, all these protocols, all these policy, how we implement, all this become important. So, there are 4 major components in SDI. I have told it indirectly, but let me be very specific. One is the policies and institutional arrangement, governance, data privacy, security, data sharing, cost recovery, all these aspects are to be dealt very nicely through the policies and institutional arrangement. That is one aspect. Then ultimately people will use it, right. So, we need training, we need professional development, we need cooperation, we need outreach. Third is actual data. So, digital base map, thematic, statistics, place name, etc., right. And then the technology, hardware, software, network, database, technical implementation plan. So, with policies and institutional arrangement, people, data and technology, these are the 4 basic pillars, I should say, right. They are the 4 basic components. Why we are doing it? Again, to summarize, we want to reduce duplication of efforts among various government departments. Not that multiple organization, multiple departments are collecting the same data, taking data from each other, but nobody is then able to update it, the whole database, because the ownership remains with someone else. To lower the cost related to geographic information while making the GIS data more accessible, if you can bring down the cost, then more and more people can access such kind of data, which is valuable and which is important for the larger society. To increase benefit of using the spatial data, available spatial data, more and more people use it for various applications, various contexts, ultimately the society gets benefited. And to establish key partnership between state, cities, academia and the private sector. So, all these are the basic goals. There are applications as I said, not only in transportation management, because the spatial data is not used only for transport, but for a large number of applications, starting from disaster response to land administration to telecommunication infrastructure, large number of domains, practically every domain which links with the service of enhancing the quality of life for urban citizens, right. They can get benefited. So, there are multiple applications including transport, and as I said that no discipline you can think in isolation, there are interdependencies, right. So, some of the applications may include, I would say that anything I have taught to you, the whole 4-stage transport planning you can do using spatial data, and wherever you are using spatial data, the spatial data infrastructure is a stage beyond that, right. So, anything what you have actually you are able to do with the spatial data, SDI is going to benefit that sector. So, we also have national level NSDI, National Spatial Data Infrastructure, at state level SSDI, State Spatial Data Infrastructure. So, it is a vertical, right, developing coordination at different levels with a kind of a one way of looking it is a kind of a pyramid structure. There are of course other ways of looking at it. So, multiple anything what I have taught, every transportation data is basically spatial in nature. So, the spatial data analysis will be beneficial, and SDI is the future. SDI can help, can boost it. Other than those, a few applications where we are working now to show that how SDI can be used effectively for improvement of transportation system. They include identification of critical links in the transportation network, right. So, the travel time varies during peak hour of peak hour, but then not every link the response of increasing traffic load is same. Somewhere the peak hour travel time may vary too much, some may be it will be more, but the variability will be less. So, considering peak to off peak, off peak to peak, and then within peak hour itself, what is the level of variation. Considering all those things, we can identify which are the critical links, which are actually upsetting the scheduling of bus movement. And once you identify, then you can take appropriate measures. Similarly, once incident happens in a network, right, maybe a traffic accident or a roadside building, there is a fire breakout or some other kinds of incident, traffic get disturbed. So, the impact of an incident will depend on where it is happening. Again, its geospatial data is important, right, that if it is right at the busy intersection or a particular road during a peak hour, the impact may be tremendous. So, but not every point, every link, every intersection, every mid block is equally vulnerable. So, how to identify vulnerable road links and intersection? Then how we can have better real time traffic control. A quick method which can tell us the real time traffic state and benefit the signal control in an urban network, and also identifying accident black spot and safety deficiencies and development of countermeasures. So, altogether I would say that we discussed not in details, there was no scope for discussion in details, but we told you that one is the new type of data which has emerged in huge volume and getting stacked over time, how that big data is important in transportation context. We quickly mentioned to you about the type of data, born analog and born digital, then the basic characteristics, and also what are the kind of opportunities and applications that can happen. Then we mentioned about the GIS, what is GIS and how its application in transportation planning could benefit us, and also shared with you briefly the concept of SDI and its potential application. So, altogether, as I said, that as one way the travel behavior analysis, the future is activity based modeling. Similarly, we expect with the advent of this new emerging thing, like the big data is going to play is coming to in a big way, is going to influence the work. GIS application is going to increase further over time, and the SDI will really boost up the kind of application of big data GIS in the transport planning context. So, the future, all these applications are likely to increase and is likely to give you a new dimension to the urban transport planning. So, with this I thank you so much, and this is the last lecture. So, with this we also close this subject, urban transportation system planning. Thank you so much.